Oh, you just mentioned clamping systems.
Well,
Maybe you
yes.
can tell us a bit more about the clamping system?
There are two types. Speaking of the DD rotary table, there are two types. As you see here, the pneumatic piston and the circumference type, the hydraulic circumference type.
Okay, so why don't we talk about the pneumatic piston type first?
Well, at Soul Power, we only use the pneumatic piston type, yes.
Oh, so those are the two main, most common
Yes, most
types?
common one, but at Soul Power, we only use this type, the pneumatic piston type.
Circumference type, you're out.
Out, absolutely, yes.
So, pneumatic piston type, tell us more.
Okay, well, the pneumatic piston type is composed of two major parts. Of course, obviously, the piston and the liner. The liner is fixed. We assemble it fixed on the DD rotary table shaft, and it turns. Obviously, it turns synchronously with the shaft, and the piston is located behind the linear, and the piston is either driven by liquid or air. The mechanism, in simple words, is when the piston moves forward, of course, it forces the linear to climb up on the motor, right? And when it moves backward, it will release the clamp.
Okay.
So as we see here, that's the way we calculate the clamping torque.
Okay.
So here, the TC is equivalent to mu, which stands for friction coefficient.
Okay.
All multiplied by P, the pressure, A, the area of the piston, and multiplied by R, the radius of the piston.
Okay, so that's the equation, how you calculate the clamping torque.
Yes.
So now you've basically turned into my physics teacher.
Sorry.
So I don't understand anything.
It has to be said, yes, sorry.
But maybe you can give us an example or tell us how, in real life, how do you test the clamping torque?
Okay, well, there is a clamping torque and a clamping rigidity. We use our UL certified bench to test the torque here.
Okay, there's a bench again?
Yes. So by coupling the load motor with the DD rotary table perfectly, then we force the piston to clamp on the motor case. Hence, in that situation, the shaft is locked.
Okay.
Yes. So gradually, after that, we'll start applying the torque until the DD rotary table turns. That moment, we'll have our clamping torque.
Okay.
Regarding to the clamping rigidity, we use the dial gauge to measure the radial deformation of the rotary table.
Okay. I think I'm slowly starting to understand it. It's kind of complex, so maybe we can illustrate it by talking about one of your products?
Sure, absolutely, sounds good. What about we talk about our largest DD rotary table, if you still remember? Yes, absolutely, the
sure.
SBB
so clamping torque, if you want to measure it for that one.
Okay, let's go. Here you go. So as you see here, after we do the required calculation, we'll get the clamping rigidity of 500 Newton meter per 3 arc second, right?
Okay, so that's the process that you just described, right?
Yes, absolutely. So let's see. When we apply a 500 Newton meter torque to the shaft, during clamping, the rotor will turn 3 arc second.
Okay.
Well, in other words, the angle degree is equivalent to 0.0008.
0.0008 degrees. Wow,
Yes.
that's crazy.
Yeah, but it's very, very common when we're talking about the DD rotary table.
Okay.
So then when we stop applying the torque, the shaft will go back to its original place instantly. And this elastic deformation is called clamping rigidity.
So that's actually what clamping rigidity means, what it is.
Yes.
Okay, a very complex process. So Sam, thank you very much for explaining it to us and for sharing your knowledge with us.
Our pleasure.
And the reason why we've been talking so extensively about all this is because we wanted to illustrate that Soul Power is not just a motor manufacturer, right?
Yes,
we also have the capabilities, the knowledge,
to
and the machines.
DD rotary tables, absolutely, and as well as the motorized spindle.
And following all important international standards.
Exactly, started from the stator and the rotor, yes.
Okay, beautiful. So we're done, I think, with our main part for today, but we want to answer a few more common questions regarding your rotary tables.
Sounds good.
Sounds great. We'll be back in a few seconds. You don't go anywhere.